I'm Anil Kumar. Welcome to my series on trigonometry. In this video, we'll discuss three multiple choice questions which are relatively difficult questions to do. Here is the very first one. You can pause the video, answer the question, and then look into my suggestions. Let me first share with you all the three questions and then we'll take their solutions one by one. You can now look at the second question, copy, solve the question, and then look into its solution. We'll actually begin with the third question, which is right here. The third question here is, if tan x plus tan y equals to 25 and cot x plus cot y equals to 30, find the value of tan x plus y. Four choices are given to you. So let us see how to solve this. When we are saying tan x plus y, it really means we can expand this and write this as tan x plus tan y over 1 minus tan x tan y. Correct? We know what tan x plus tan y is, that is, we know the numerator. However, we do not know what is the product of tan x and tan y. To find that, what we can do is we can utilize this condition, which is cot of x plus cot of y equals to 30. Cotangent is 1 over tan x, correct? So that could be written as 1 over tan x plus 1 over tan y equals to 30. Taking a common denominator gives us the product of tan x and tan y in the denominator, and in the numerator we get tan y plus tan x, which should be equal to 30. Now from here we can cross multiply, and we know what tan x plus tan y is, which is 25. So let's do it in two steps. So we'll write this as okay, so let me write this as 25 over 30, right, equals to tan x tan y, correct, which is basically dividing by 5, we get 5 over 6. So I hope this step is clear to you. What we did was that we actually cross multiplied and replaced the numerator, which is tan x plus tan y, with 25, correct? So we got here 25 over tan x tan y, and then we cross multiply, right, to get this step. Clear? So we get the value of tan x plus tan y equals to 5 over 6. Now we can substitute this value here. We know tan x plus tan y is 25, which is the numerator, and in the denominator we get 1 minus 5 over 6, correct? Now let's continue with this simplification. We get 25. Here we could write this as 6 minus 5 over 6, which is 25 times 6 over 1, right, which is 150. So 150, which is the option C, is the correct solution. Is that clear? So that is how we are going to solve this question. Now let's take the other example. In this example, if sine x plus sine square x equals to 1, we need to find the value of 1 plus cos square x plus cos to the power of 4x. Okay, so what we are given here is basically sine x plus sine square x equals to 1. Now we can write sine x as equal to 1 minus sine square x. That means sine x can be written as 1 minus sine square x is cos square x. Clear? So we could replace sine x with cos square x. Here we have cos square x. We also have cos to the power of 4x. So that basically implies that we could write sine square x as equal to Squaring both sides, we get cos to the power of 4x. Correct? So we get one condition here, which is sin x equals to cos square x. And when we square both sides, in that case, we get the second condition, which is sin square x is equals to cos to the power of 4x. Correct? Now, we need to find what is the value of 1 plus cos square x plus cos to the power of 4x, right? It's much simpler now. So we need to find what is 1 plus cos square x plus cos to the power of 4x. Now, cos square x is sin x. We can write this 1 plus sin x. And cos to the power of 4x is sin square x. Clear? Now, we are already given that sin x plus sin square x is basically equal to 1, right? So we could write this as 1 plus 1, which is 2. So D is the right option. Clear? So that is how you could actually solve this question. Now let's take the last example, which is slightly tricky. You need to find the equivalent expression for secant to the power of 6x minus tan to the power of 6x minus 1. We are given 4 choices. You can always pause the video, answer the question, and then look into my suggestions. Now, we have powers of 6, so we could actually factor this using the formula for a cube minus b cube. Now, a cube minus b cube is a minus b times a square plus ab plus b square. Correct? So that formula can be utilized. So let's begin with secant to the power of 6x minus tan to the power of 6x equals minus 1. Right? So what we have here is secant to the power of 6. So I could write this as secant square x whole cube, right? Minus, similarly I could write this as tan square x whole cube. So we get 6 power, right? Minus 1. So that is how I could write my expression. Now we'll apply this formula of a cube minus b cube. So what we get here is secant square x minus tan square x, right? That is a minus b times. We have a squared, so we get secant to the power of 4x plus product of these two, which is secant square x tan square x. And then we have to plus tan to the power of 4x, and then we have minus 1. Clear? That's what we get. Now, secant square x minus tan square x is 1, right? So I hope you remember, we have 1 plus tan square x equals to secant square x. So you could actually take tan square x to the left side, right? This has 1 equals to secant square x minus tan square x. Clear? So that means this portion here is 1, right? Since this is 1, we could write this expression as secant to the power of 4x plus secant square x tan to the power of 2x plus tan to the power of 4x minus 1. Now, to continue, it'll be good if you could just convert them to sine and cosine. So secant is 1 over cos. We write this as 1 over cos to the power of 4x plus, that is 1 over cos square x. This is sine square x over cos square x. Here we get sine to the power of 4x over cos to the power of 4x minus 1. Well, we can take cos to the power of 4x, which is in the denominator, as a common factor. So taking cos to the power of 4x, we get the numerator as 1 plus, here we get sine square x, here we get plus sine to the power of 4x, and this one will get multiplied by cos to the power of 4. So we get minus cos to the power of 4x. Clear? We want something in terms of tan and secant, right? So, okay, somehow we should get the numerator. Let's write this sine to the power of 4x in terms of cos. See what do we get. So we could actually write this as 1 plus sine square x. And then we don't have any power of 4. So it is a good idea to write this sine to the power of 4x, means sine square x whole square, right? So we could write this as 1 minus cos square x whole square. Is it clear? Minus cos to the power of 4x over cos to the power of 4x. Now expanding, we get 1 plus sine square x plus, we get here 1 minus 2ab means 2 cos square x plus power of this, which is cos to the power of 4x minus cos to the power of 4x. So the last two terms can now cancel, so we get slightly simpler expression. So we get here 1 plus sine square x plus, okay, so 1 plus 1, this we can add to get 2 plus, right? So we are adding these two ones. We are getting 2 here. Sine square x. Cos cancels and we have minus. We have minus 2 cos square x over cos to the power of 4x. Now we'll write sine square x as 1 minus cos square x, right? So we could write this as 2 plus sine square x, I'm writing as 1 minus cos square x. We already have minus 2 cos square x divided by cos to the power of 4x. Clear? So 2 plus 1 is 3 and we get here minus 3 cos square x. Okay, so let's take this term on the left side here. Since we are running out of space, I don't want to do it further in new page, so we'll just take this from here to this place. So we have here 3 minus 3 cos square x over cos to the power of 4x, right? So that's what we get. We can take 3 common, right? So we get 3 common. We get 1 minus cos square x over cos to the power of 4x. Now 1 minus cos square x is sine square x. Right, so it was better if I would have converted this cos square x into sine square x. Then I would have got it direct, right? So we get here 3 sine square x over cos to the power of 4x. So that is 3 times. We could now write this as sine square x over cos square x times 1 over cos square x, right? Since we want tan and secant. So that means we get 3 tan square x secant square x. Clear? So the option C is the right option. Correct? So that is how we could actually answer this question. Now this is pretty long to prove. In a multiple choice question, what you could do is that you could substitute a value for x, right? Okay, so strategy, well, this is the actual solution. Strategy is, in such cases, substitute some value of x, right? X equals 2. You could take some value. 45 degrees will actually give you tan as 1, right? 1 over square root 2 for secant, something like this, right? So if you use that kind of a value, we will be in a position to figure out what is the right option. So if time is a constraint, you could always substitute some value for x and figure out what does the right answer relates to, correct? However, the proof is pretty long as shown here. I could have cut short here at this stage. Instead of expanding sine square x, I should have expanded cos square x. Writing this as 1 minus sine square x would have cut down by 2 steps that we could have done. Otherwise, this is how you are going to prove it. So I hope you understand and appreciate it. As far as the strategies go, in a multiple choice question, you should definitely try some values for such a question, right? The previous two, You could prove and you get the answer within a minute's time, but here it's better to use a substitution of some values and then check them out. Correct? So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.